everybody, we are officially starting our new notebook. So I took some advice from some people and they said that it was kind of hard to like see the screen and type at the same time. So our notes now are going to be all handwritten, but you're still going to be uploading pictures into your notebook so it's easy for me to be able to grade and all have everything in one place. So first thing you guys can do is get your Unit 2A Part 2 workbook and put your name right here where it says add your name. If you want to go over to slide number 5, that's our table of contents slide for this little notebook, and you can fill in your slide number 6 is the only slide we're going to be on today, and it's solving one variable equation. So you can pause here and type that in. Okay, so for our notes, I did make like a kind of like a skeleton PDF form that you guys can look at or can print if you want and fill it out, or you just handwrite everything. Totally fine. Okay, so you can just handwrite everything. You don't have to worry about printing it. You can just handwrite on a piece of paper. Okay, so the essential question, what we're going to want to answer today is what are the steps for solving a one variable equation and why is it important to do the same operation on both sides of the equation. You don't have to write that down on this notes page because it is located in the sticky note to the left hand side of the page where your slides notebook page where you're going to put this. Okay, so when you're solving an equation you have a goal. Okay, so your goal is to find what number the variable is equal to. That's your goal. You want to find what number is your variable equal to. So your answers today are going to be x equals 5 or t equals 2 or whatever variable equals a number. Okay, so we're going to look at some steps right now. So the first step, the first thing you should always look for is, do you have a fraction? That's like the first thing that you want to tackle. People don't usually like fractions, so usually that's the first thing that you're going to probably try to get rid of. Okay, so it says fraction question mark because obviously not every problem is going to have a fraction, but if you have a fraction, you're going to want to isolate it to one side then multiply both sides by the reciprocal to cancel. We'll see an example of this in our notes. Okay, so after you get rid of your fraction, okay, or maybe you didn't have a fraction to begin with, that's okay. Then you're going to want to get rid of your parentheses. So not every problem's going to have parentheses, but if you have parentheses, that's kind of what you want to go ahead and kind of get rid of it kind of at the beginning, okay? And in order to do to get rid of the parentheses, you just use the distributive property to multiply. So you undo using the distributive property. Oh, I can't say that right. So the distributive property is where you take whatever's on the outside of the parentheses and just multiply whatever's on the inside. Okay, if you have like terms on the same side, so when I talk about sides, I'm talking about the equal sign. Okay, there's a left side of the equal sign and a right side of the equal sign. If you have like terms on the same side, you want to go ahead and combine those. All right, then from there, you want to look at, do you have variables on both sides? So if you have variables on both sides, what you're going to do is you're going to undo one of the variables. So you pick. A lot of people always move their variable to the left. Some people move whichever one has the smallest coefficient. Sometimes they always just try to make it positive, whatever it might be. You just want to undo your variable from one side using the addition or subtraction property. So the whole point, or the whole important part of doing something to both sides, is the problems are equal, right? That's equal. There's two sides. The left side is equal to the right side. If you move something, you add something, subtract something to the right side, but you don't do it to the other side, you no longer are equal because you subtracted something out. It's like a balance. And if you subtract or add something to one side of the balance, it's going to outweigh or be lighter than the other side. So you have to try to keep them balanced. All right, then you look at, do you have a constant with your variable? So remember, a constant is just a number without a variable. So then you're going to go ahead and undo the constant. That's on the same side as the variable. By adding or subtracting. Remember, whatever you do to one side, you have to do to both, or else it won't be equal anymore. All right, then we look at, is there a coefficient on our variable? If there's a coefficient on your variable, then you're at your last step. You just have to undo it by multiplying or dividing. So notice how they all said question marks, because not every problem is going to have a fraction, parentheses, like terms on the same side, variables on both sides, a constant with the variable, coefficient of the variable. This is just kind of a checklist. Does it have this? Then do this step, then move on to the next one. At the bottom, I just have a couple of little starred pieces of information for you, is that you should always check your answer, or check your solution. I understand you might not always do this every single time, but maybe it's important on like a test or a quiz or something. You want to check your solution to make sure that it works. And to do that, you just plug it back in. And then that other little remember is just what I said. What is done to one side must be done to the other. To keep the equation balanced. Okay, so this is one side. Like, you didn't have to print out this PDF, but I am going to do two sides. So you can either like flip to the back side of your paper because you're going to take two different pictures, or you can just take two pictures. You're going to put these notes on the left-hand side of our slide and then the examples on our right-hand side. I'll show you. So this is like what your slide looks like. Everything we just wrote down is going to go over here on this side. On the left, and then on the right hand side you're going to put your examples there. Then remember, we already have the essential question over here on the slide. Here's a place for you to add questions, and then a place for you to summarize. Maybe not necessarily what you've learned today should definitely be review, but you can just summarize, answer the essential question, summarize what the notes were about, that kind of thing. So we're going to go do our examples. So what we just wrote down, you'll take a picture of that. It will go on the left-hand side of slide 6, and then on the right-hand side, you'll put your examples. We just have 4 of them. Okay, so for number 1, it says 7x plus 6x minus 7 equals 32. So I kind of go down that checklist. I'm like, are there fractions? No. Are there parentheses? No. Are there like terms on the same side? Yes, I have like terms on the same side of my equal sign. So some people, it helps to like draw a line that there's two sides of the equal sign. So I'm going to go ahead and add what I have on this side. So 7x plus 6x is 13x minus 7 equals 32. All right, so I just combined like terms. Then I look at, are there variables on both sides? So I don't see variables on both sides. I just see one variable, the letter x. There's only one of them. There's not one on the other side, so I can skip that one. Is there a constant attached to your x? Yes, so there's this number -7 right here. Well, to get rid of a -7, we do the opposite sign. We undo it by adding it to the other side. So remember, you have to keep it balanced. So if you do that on one side, you have to do it on the other. Now I get 13x equals 39. And it says to see if there's a coefficient in front of the variable. There is, and the way you get rid of that is just by dividing both sides by that coefficient. And we get x equals 39 divided by 13 is 3. So as I said, you might not check your solution every time, but I just want to show you guys how you would check your solution would be to take your answer you got and plug it back in for the x. So our problem said 7x plus 6x minus 7 equals 32. So I would plug in 3 where the two x's used to be. And that gives me 21 plus 18 minus 7 equals 32. 21 plus 18 is 39. Is 39 minus 7 32? Indeed it is, so it worked. So if you don't get something that's equal, then you know you made a mistake somewhere and your answer is not right. Okay? All right, let's do number 2. So number 2 says 5 parentheses x minus 7 plus 2 equals negative or minus 9 parentheses x plus 16. So first off, do we have any fractions? No. So then we're going to go to parentheses. Are there parentheses? Yes. We want to go ahead and distribute to get rid of those at the beginning. So when you distribute, you multiply. 5 times x is 5x. 5 times -7 is -35. I add my 2. Distribute my negative sign. My positive x becomes negative. My positive 16 becomes -16. Then I move on to, are there like terms on the same side? So yes, there's like terms right here. We can combine these two together. So I get 5x minus 33 equals -x minus 16. And I'm just going to keep moving along. Do I have variables on both sides? Yes, I have a 5x here and a -x here. So I need to get those on the same side, okay? There's two sides of the equal sign. So some people always move their variable to the left. Some people choose whichever one's smaller. Either way is fine. So I'm going to move my minus x by adding it to the other side. So if you take this minus x, you add it onto both sides. That makes it cancel on one side. That whatever I did to one side, I had to do to the other to keep my equation balanced. All right, then I see if I have a constant, I do. So I'm going to add my 33 to both sides. I'm just doing the opposite operation. I get 6x equals 17, I believe. And then I just have to get rid of the last thing, my coefficient. So to do that, I divide both sides by 6. Kind of ran out of room. I get x equals, can 17 be divided by 6? Not evenly, so we're just going to leave it. It can't even be simplified, so I'm just going to leave that as my final answer. Okay. All right, let's move on to number 3. All right, number 3, do we have fractions? Yes, I see a fraction. So what we're going to do is we're going to isolate that fraction on one side before we do anything else. So I'm going to go ahead and add this 9 to both sides. So that as you guys can see now on this left side of my equation, I now have my fraction equals 10. So remember how I said in our little notes that you can multiply by the reciprocal? I'm actually not going to do that for this problem. What I'm going to do is I'm going to multiply by whatever we're dividing by, because what this really says is 3x plus 7 divided by 4. Okay, that's what that little line means. This little line right here means divided by. So in order to undo division, I'm going to go ahead and use multiplication. So I'm actually going to multiply both sides times 4. Technically, I'm multiplying by 4 over 1, right? Well, the 4's are going to cancel, and now I have 3x plus 7 equals 40. 10 times 4 is 40. So if you're dividing by something, you can just multiply by whatever's in the denominator, and that will cancel it, and I no longer have a fraction. So I isolated the fraction, and then I just multiplied by what was in the denominator. And now it's just a two-step equation, 2 steps. Subtract 7, divide by 3. X equals 11. I forgot to check my answer on the last one, but remember the way that you can check your answer is just to plug it back in to the original problem, and make sure that it holds true. So my original problem was 3x plus 7 divided by 4 minus 9 equals 1. So I'm plugging in 11 for my x. I get 33 plus 7 divided by 4 minus 9 equals 1. Well, 33 plus 7 is 40. 40 divided by 4 is 10. And 10 minus 9 equals 1. Check, that works. Last equation, it has a fraction. So that's the first thing that we're going to get rid of. I always like to isolate my fraction at the beginning. It's possible you could have multiple fractions. If you have multiple fractions, instead of multiplying by the reciprocal, you multiply everything by the lowest common denominator, like whatever you would find as your lowest common denominator, you multiply everything by that. Okay, so I'm going to isolate my fractions. I'm going to subtract 14 on both sides. I get 2/3 x equals negative 12. When you do 2 minus 14, the bigger number is negative. 14 minus 2, though, is 12. All right, so here's what I was talking about when I was mentioning the reciprocal. So the reciprocal means you flip. So I'm going to multiply both sides by the flip of 2/3. So when you flip 2/3, you get 3/2. So when I do that, what happens is my 3 cancels because I'm multiplying and dividing by 3 at the same time. My 2 cancels because I'm multiplying and dividing by the same time. And now I'm just left with x. Over here, when you multiply, might help to like show out our work. When you multiply, you would want to change your whole number to a fraction if that helps you. And then what you do is you multiply straight across the top, straight across the bottom. So we get x equals negative 36/2. And that gives me x equals negative 18, right? And then again, you could check your answer by plugging it in. 2/3 of negative 18 is negative 12. Negative 12 plus 14 is equal to 2. So these 4 examples that we just did, this little paper, you're going to go take a picture of them and put them over here onto slide 6. So we're not doing any like fill in the blank, typing in things. We're just going to handwrite our examples this unit and see kind of how it goes, if it goes well. You know, if it doesn't go well, we'll go back to what we had before, but for this unit, that's what we're going to do. So those are the only 2 things that we're going to take a picture of. You want to do it right away. Don't wait till the last minute and then not be able to turn in your notebook because you didn't go add the pictures in. So add in your pictures now, and then your homework will be some solving equations problems, okay? Just a small review of something you guys have done before. All right, bye.